to the Tin Barn. I'm Pragmatic Lee, and today's project is going to involve making a couple more tool holders. But these are going to be a little bit different. In my original set of tool holders that I've got with my quick change tool post, of course we all get the standard tool holders, and usually get something to hold a parting blade. But there's also these kind of heavy duty ones for holding boring bars. One of the first things I did after I got my the lathe I'm using now and this set of tool holders for the quick change tool post, I made a couple of adapters to go in this. This is a 5/8 bore in here, and I didn't have any any boring bars near that big, so I made a couple of adapters. This one has a 1/2 inch hole, and this one has a 3/8. And they're for those, sets like a lot of us have got. This is a 3/8 set. I've not used a whole lot of those. They are kind of small, but then got the 1/2 inch ones as well. But what I want to make today is some tool holders for these boring bars. This is one. This is a 3/8 boring bar, and this one's a 12 millimeter. Approximately 1/2 inch. And they work okay putting them in the regular tool holders. They got the flat on there so that you get them lined up right. But these tool holders just don't have the weight and the beefiness that these do. So what I'm going to do today is make a couple of tool holders, one to hold this 12 millimeter and one to hold this 3/8. And what I'm going to use for that is this piece of 2-inch stock, and it is some rough stuff. This was an old axle that I think was probably a trailer axle I found in a trash pile. I've already cut the spindles off of it. I've made a couple items from this, in the past. It's very pitted. It's got some bad rust scale in it, and most folks say, well, if you got a piece like this, go ahead and set your lathe, or in this case your mill, deep enough to knock all that rust off at one time. My mill is just not sturdy enough to do all that. So I'm going to set this up in some vinegar and try to knock this rust off overnight. I'm not going to give it a full 24 hours. I'm just probably going to give it an overnight soak, and then we'll put it in the mill and cut it down to size. This started life out as a 2-inch square. This is 1.5 by 2 inches. By the time I get the pits and everything out of this and get this cleaned up, it won't be a full 2 inches on this side, but it'll be much beefier than these. So I'm going to get this set up in a pan and start sucking it. All right, what I'm going to use to soak it in is just a small loaf pan here. It's pretty much got plenty of rust on the inside too. But what I'm going to use a couple of pieces of scrap down here just to set that on, so that the vinegar gets all the way around, and be sure that it's deep enough to cover everything. So wife just got back from the grocery store and got me some vinegar. So let's see how this does. All right, that's got it covered. Wouldn't have cared if the loaf pan had been a little bit deeper. What I may do is reach in there and turn the side up that I know I'm gonna have to cut down considerably. This has got a deep pit over in this side over here. And like I say, I'm going to be cutting it down to an 1.5 inches. So I'll just turn that edge up there in case it does evaporate some overnight. I don't have a full day to leave this, but I'm going to leave it about 19-20 hours and be back in the morning to see how it's done. The overnight soak in the vinegar did a good job of removing the majority of the rust on there. It didn't penetrate deep down in some of these holes. I think if I had maybe a couple of days to let it soak in the vinegar, it would have done more. But it did remove a lot of that crusty rust off the top that's so detrimental to an end mill. So we're going to go with this, but what I'm going to do first is bring the Z-axis down and zero it out on the bottom of the mill vise. All right, there's 0 on the Z-axis. Now I'm going to move up 1 inch 600 thousandths. We get to that and I'll explain to you why that number. I want a finished dimension of 1.5 here on this side. I'm going to have to take some of this bottom off here, so I'm leaving 100 thousandths on this bottom down here to get rid of any pitting on that side. It's not near as bad as this top edge here. This top edge, or what I'm making the top edge, is pretty rough. Now, to verify, to get down to that, I am clearing my jaws on the vise. So I've got the DRO set at 0 now. Slide it on up out of the way and tighten this down. And what I'm going to do is start out milling here, seeing how much I can take at a time. I got a 5/8 inch end mill in there now. And we'll take this down until the DRO is back at 0. Be approximately 400 thousandths to take off here. That's showing 394 right there, 395. All right, let's see what that's going to do. That's about 80 thousandths there, 85 thousandths. All right, I need to go turn the open air line from the air compressor. So I've got air to my mister here. I'll pull the curtain over so I don't blow chips all over everything. And I'll bring you back when we get a little bit closer here. Okay, we're on our last pass now, clearing the mill vise fine. I was taking depth of cut about just a little over 100 thousandths for each depth, for each cut. And with the 5/8 end mill, it's taking 4 passes across there. Or about three and a half passes to mill the entire surface. Okay, that's got the first surface finished on there, got the worst one. We were taking approximately 395 thousandths in 100 thousandths depth of cut across a 2-inch wide, and that air and mister has kept it cool the whole time. There's no heat on the end mill or the workpiece. So conventional wisdom would say, all right, let's flip this right over and do the opposing side of that. But we're not going to do that. I'm going to dry that off, and I'm just going to put an R on here. This is going to be our reference surface right here. Probably need to take the file and knock a little bit of the edges off here. Just get some of those burrs off the edge. Now I marked that as a reference because we're going to use that as our reference. We're going to turn it to the fixed jaw. And this is flat enough that I don't need to put anything in there to hold it. If it was a small piece, I'd be a little bit concerned about it moving in there or not having a grip. But we're across the whole width of the vice jaws. So I've got that in with our reference surface against our fixed jaw. And all I want to take off of this is just enough to get to the bottom of whatever the deepest pit is on this. So I'm going to touch off 0, and then I'm going to start with, I don't know, about 25 thousandths. And if I start seeing where it's not clearing the pits, I will come back. I want to leave this dimension as close to 2 inches as possible though. All right, I'm already seeing that that's not getting to the bottom of the pit, so I want to try another 25 thousandths. And we'll give this a run and see how that does. All right, that's got the second side done. I didn't have to go any deeper on there, so I wound up taking about 50 thousandths off of this side. Now, we're going to keep, remember this is our reference surface over here. This is the surface we did first. This one now is square, perpendicular with that one. So we're just going to go an end-to-end flip. Be sure everything's clean under the vise. Flip that over, got it seated. In the bottom of the vise now, we've got a good reference surface on the back. We've got the second surface square on the bottom of or flat on the bottom of the vise. So now we're ready to come back, and I'm going to try again, starting out with a shallow cut. That's the 0. And I'm just going to start, this side doesn't look bad at all. I'm going to start with a 15 thousandths. I may have to come back and get a little deeper. We'll start with 15, see how that does. We'll go on down to 25. Those little rust pits, they can be deep. Okay. We'll have to have a little more. There's a total of 40 thousandths. And I'm going to try this and just let it go with that. All right, now the opposing side is done. So what we have from our reference surface here that we started with, we've got 2 parallel sides that are perpendicular to our reference surface. There is square, perpendicular, parallel as my vise on my mill tram, and as far as I know, that is good right now. I'm going to knock that edge off just a little bit. Got a little roll burr there. now we're ready for this final surface, and I want to be sure that I'm not going to run into we want that surface to be 1.5 inches. So just like we did on that very first surface, I'm going to come over here and touch off the mill on the bottom of the vise. Zero out the Z-axis DRO. Come back to 1.5 inches. Now I want to be sure that clears my mill, my vise jaws, and it does. So I will zero out the DRO again. Now, and I believe I've got the DRO zeroed. Let's see how much that shows. Should be around 100 thousandths. 96 thousandths. We should be able to take that all in one pass. Again, bring my DRO back to the 0 that I set and lock the quill down. My coolant's getting very low, but I think I've got enough to finish this project up. Okay, got the all the rust off the block now. Got it squared up. Our long side that we wanted to leave as close to 2 inches as possible. We're at 1.89. So we lost about 100 thousandths on that side. The side we were shooting about for 1.5 inches. We're within 1 thousandths, 2 thousandths right there of being 1.5 inches thick. So we're perfectly fine on that rusty old piece of material. Now before I cut it in half, saw it in half to make the 2 blocks out of, or the 2 board and bar holders out of, we've got to do something about these ends right here, and it'll be easier to do it while it's all one piece. As you can see, the saw cut on that end is not straight at all. My saw cut on this end, my last one, is butter, but it's still not square. Now, if this was a thin piece that the end mill would reach all the way down, it would be just a matter of setting it in the vise, running the end mill across here, and be done with it. But the end mill is not going to go deep enough, so we're going to have to turn this. We're going to have to go part the way, flip it over, and do the other part. And again, if it was a short piece, we could put a stop here on the vise and bump it up to it. But the problem with that is, and even with putting a work stop out here, we got such an irregular surface. If we put the work stop up here, then we turn that long edge is going to move this in. We want to keep this in on the same plane. So I'm going to get that set up to where we can rotate this piece as many times as we need to, but keep this end on the same plane. Okay, working with old metal that you can find like this, old rusting metal, you're going to run into situations where you need to square off the ends, face them off, and again, setting a single work stop over here somewhere, we could set it on this longest point right here, or whichever one's the longest point. But the problem is, if this was the longest point, Now we rotate our piece and it's bumping against that point. If we were able to find the perfect center in there, we might could put a pointed work stop over here on our mill and do reasonably well. But to get it correct, I think personally, and I'm wide open for comments, if somebody knows a better way, please let me know. But what I've done is took an angle block here, and that I know is 90 degrees. I've set it up on the vise or on the mill table, squared, checked it that way, checked it on the back side, and in previous times of using this, I've actually put an indicator in there after squaring it up with the front edge, put an indicator on, and it will square with the spindle going this way. And what you want to do is be certain, this is a slotted angle block. It's got slots in there. Before you start doing your work on this, I would start with the worst edge. And let me zoom in a little bit for you. What you want to do with if your block has the slots in like that is be sure that the longest point, just put it in your vise, slide it up there, and be sure the longest point is not inside one of these slots. Bump it off there. Now rotate it 90 degrees, keeping up with where that longest point was. It's right there. It's not in the slot there. Rotate it 90 more degrees. It's not in the slot. And back to where we started. It's not, or now it's down here. It's still not in the slot. In our case, we're going to need to turn this just one time. So I'm going to set it in there like that. Bump that up to it. You don't have to slam it up there. Just bump it up there to it. Being sure, again, when you're doing all these measurements, that there's not some rolled over chip over there. Now I'm going to come back down here to this end, run the end mill a little over half the distance, facing that off flat. Then I'll go to the other end, do the same thing down, or I'll turn it around, having a square end then, and face off that end. All right, now that I'm sure I've got the angle block set in position over here, and I've got clearance and everything in every direction, I'm going to look at this end and find where my shortest point, visually just look and see where my shortest point on this rough cut over here. And that is right along on this corner. I've already determined that I'm fine on this end, no matter how I turn it. I'm going to tighten that in. And I want to go down just a little over half. Lock the Z-axis down. And that shortest point, again, I'm going to touch there. In this case, I believe I can get that all in one pass. But what I'm going to do is touch off in the center and just work it that way. There's no need of putting any extra burden on the mill than we have to on here. So, and I'll use a little cutting oil on this one. Now I should be able to go on in. This was the end that was not very bad at all. That's not quite getting it, so I'm going to throw a few more thousandths. I'm going to go back, taking just a minor cut on the climbing direction. Now while I'm right here, in case I move something that I don't intend to, I'm going to go ahead and set the 0 on the Z-axis, or on the X-axis. Get those little needles out of the way. Now, if this was a wider piece, we might need to turn it up and do it in this direction. And then again in that direction, the fourth. As it is with this one, we can make it just one turn. Now, the reason for setting that Z-axis, if this was a bad corner that I had to move out like that other end is likely to be, I would want to be able to come back to the exact same point I was on this one. So we shouldn't have to move our X-axis at all now. I believe I can take all this in one cut. And there we have a good end. I can just barely feel that joint right there. Just barely feel it over there. Again, I'm wide open for comments. If somebody knows a better way of doing that, bring it on. Let me hear it. But now we can turn this, and I'm just going to leave the block right in there. And that shows me it's touching all the way around. Let me go ahead and get this long end first right here. All right, we've got it turned around now. Butts up square. I'm going to put this sharp point, or the shortest point, right here to start working off of that again. And I'm going to do basically the same thing I did before. And I'll bring you back when we're ready to carry it to the saw and cut it in half. All right, to clean up the shortest point on this other end that was in such bad shape, I actually had to go in 190 thousandths from where we set the other zero. So there's no way I want to try to cut that much on the side of an end mill one time. So again, I'm going to zero out my X-axis and take the piece out now, being sure I don't pick up a chip in this end. Now, again, I don't want to try to take that full 190 thousandths at one time there. So I'm just going to back off, but by having my DRO set to zero, I can work myself back to zero and should be on this same line here, same plane. Okay, this end is faced off now, and I can see the line there between the two surfaces, but I cannot feel anything on this end. So I believe that's about as square as I can get that without a surface grinder and so forth. So what I'm going to do now is measure this. It's oversized, but I'm going to measure this, carry it to the bandsaw, and make two pieces out of it. And then we'll come back and use a little different method to clean up these new saw ends. Got the two pieces sawed in two now, but I made the single piece long because I knew I couldn't make a good straight saw cut. And as you can see, there's 150 thousandths difference there, but I've got some cleaning up to do here. But I've removed that block now because obviously this is not long enough to stick all the way through. But what I'm going to do is put this little work stop that clamps onto the mill vise. I'll fix that to the fixed jaw. And because we've got one end that we know is square, I can bump up to it no matter how I turn this. But the opening in the vise down here sometimes can present a problem. So I'm just going to lay a parallel in there, and then the piece is not going to fall down in. So each time I'll simply bump it up to that workpiece, mill to length. This one, we want these 3 inches long. So I'm going to make this first cut across here, going about half the distance, a little over half the distance again. I'm going to make it down until I'm 3 inches on this. Zero out the DRO, and it will stay there for the entire cut, or for both cuts on both pieces. So I'll bring you back when we get that pretty much to the finish, to the end on there. All right, I've made a couple passes across there enough so that I've got it cleaned up now, and I'm just going to get a rough measurement there. And that's 3.17 178. So I will zero out the x-axis there and work down to get a little closer to zero. Or to 3 inches. It's too wide even for my 3-inch mics right now. All right, I've got the first side of the first of our 2 pieces here. Remember, I put the work stop on here. I've got it sitting on a parallel. And I've brought this down to exactly 3 inches right here. And I'm setting my zero on the x-axis on my DRO. I'm setting that to 0. So when we flip this, I'll bring this to 0. And then when we bring the other piece in there, we'll bring both sides of it to 0 as well. All right, we started with a pretty crusty, rusty piece of old wagon axle, I guess is what it was. And I've got us 2 nice pieces of material to work with now. They're 1.5 inches by 2 inches by 3 inches long. Actually 2.9 or 1.9 wide instead of 2. But that's perfectly fine for what we've got here. I've got a mass of these needle chips down here, and they're getting everywhere. I just pulled that one out from the inside of my apron. So I'm going to break for a bit, clean all these up. As a matter of fact, this is probably a good place to end part 1. We'll come back for part 2. We'll put dovetails in these, drill our hole for the boring bars, and put our locking screws in there.